Hey everyone, we are Team Levin and I am Srivatsava. We are here to talk on Tesla coil, and the name itself signifies what we are talking about. Nikola Tesla, this extraordinary genius, had a dream of powering the world wirelessly, going over all the limitations of traditional power cables. So let's get into the topic. Coming to the history of Tesla coil, it's all started with the invention of Leyden jars, simply we can call them as first generation capacitors and transformers followed. And Nikola Tesla made use of both of these to create this Tesla coil. Let's see what a Tesla coil basically is. A Tesla coil is a simple radio frequency oscillator producing high voltages with a frequency of range 20 kHz to 100 GHz. The basic principle behind the working of this Tesla coil is resonance, and this is how it look like. You can get a look of it. You can see the circuit. Coming to the working procedure, from the previous picture we can observe from the figure it has two transformers. In them, the first transformer, let's say the supply transformer, the primary coil is connected to the AC voltage and steps up the produce high voltages of 2 kilovolts to 30 kilovolts, which in turn charges the capacitor, and this accumulation of massive charge in the capacitor gives huge amounts of current, breaking down the air of spark gap successfully. We can have a huge voltage at the output. Let's have a more insight on working of this wireless power transmission device. When the gas of air between the sparks gaps is ionized due to release of large currents from the capacitor, the circuit gets completed and the current flows through the primary coil of our second transformer, and there is a rapid back and forth between the plates of the capacitor, generating a radio frequency oscillation current in the primary circuits at circuits resonating frequency. You can simply say it's LC or something like that. The oscillating magnetic field in the primary coil in turn produces current in secondary coil, and there we can notice the potential difference in the secondary coil, which in turn acts as a capacitor, and we call it parasite capacitor. We can explain it by simply observing that the secondary coil has a potential difference, and thus we assume a capacitor there, and we named it a parasite capacitor. The oscillating currents in primary and secondary coils gradually die because there is a lot of energy dissipated as a heat at spark gap and resistance in the coil. And this Tesla coil keep on working until the current through the spark gap is enough to keep the gases ionized and keep the circuit closed. And this cycle repeats again when the supply transformer charges the capacitor again, and that capacitor C1. Now let's see the significance of this Tesla coil. Nikola Tesla's dream of wireless power didn't go into vain, and still serving this purpose even in the modern world of semiconductors. We use these Tesla coils in aluminum welding, artificial lighting, spark plug ignition in cars, high vacuum tubes and arc lighters, and many more. The main advantage of this device is that it has a simple circuitry and it's economically efficient way of developing wireless power transmitters. Now let's have a look at a short video regarding Tesla coil.
Nikola Tesla is probably one of the most appreciated scientists in the field of electronics because of all the inventions and technological advances that we use to this day. The two topics most influenced by him are the use of alternating current and wireless power transmission. And it is precisely the latter of which I want to talk to you in this episode, as specifically through one of his most recognized inventions. In this episode we will see how a Tesla coil works. it is easy to assume that we could apply current to a coil to generate a magnetic field, and in turn use this magnetic field to induce a current in a nearby coil, with which we would be transmitting power wirelessly. The problem with this idea is that magnetic fields lose their strength quickly as we move away from the source, and therefore, when separating the two coils, the energy transmission becomes more and more inefficient. Now let's see how the Tesla coil overcomes this limitation, taking this concept to the extreme. The logic is the same: to make an alternating current go through a coil, but with extremely high voltage and a specific frequency to be able to transmit energy over greater distances. To achieve this goal, there are mainly two concepts that we must understand. The first is the voltage rise through a transformer, which in simple terms is made up of two coils. A primary winding, which is connected to a current source and generates a magnetic flux, and a secondary winding, which converts again that magnetic flux in a current. But the interesting thing is that if the number of turns on the secondary winding is greater than the number of turns in the primary winding, an output voltage larger than the input is generated. Primary coil affects the secondary coil. That is, if an alternating current wave enters by the primary coil, the wave that will come out of the secondary coil will have the same shape, but with a different voltage, a high magnetic coupling between the two coils. With this, we will obtain an alternating current with higher voltage, but whose frequency is equal to that of the initial source, say 50 or 60 Hz. This new alternating current is brought to a resonant circuit with its corresponding capacitor and inductor, which is usually called the primary coil, also including an extra component which serves as a switch, which basically consists of two pieces of metal that are extremely close, but not touching. The function of this section of the Tesla coil is that the primary coil emits an electromagnetic field with the frequency of the resonant circuit. When the transformer induces a current, charges begin to accumulate in the capacitor without having any other possible way. But as the source voltage grows with each oscillation, the electrons try to find another path. An electromagnetic field oscillating at this same frequency, which we can take advantage of with the secondary coil. Again, we will have two coils nearby, and with a big difference between the number of turns of each, which means that we will have a second transformer in our Tesla coil. This will increase the voltage in the secondary coil, which, by the way, if we analyze independently, is connected to ground, and in its upper part it has a metallic piece of toroidal shape. It has this shape mainly to be able to accumulate a greater charge and prevent it from ending up escaping into the environment by the corona effect, and therefore also preventing the voltage of the assembly from increasing further. Well, the top of a Tesla coil is just the opposite. Or at least attempts to be, because by preventing charges from moving into the environment they begin to accumulate. And finally there comes a point where, again, the potential difference will be enough to ionize the air around it. But this time with much more energy, because we had more accumulated charges and ready to jump, generating the electric shocks everyone knows and loves from Tesla coil. The last detail of the operation of a Tesla coil is in the form of the primary coil, which is designed with the aim of reducing the magnetic coupling between both coils. In practical terms, this means that when a voltage oscillation goes through the primary coil, the secondary coil will generate a higher voltage for the difference in the number of laps between both coils. But it will also continue to oscillate, even if the primary coil stopped working. The electrical discharges in the air are striking, but in reality do not fulfill any function. We could even say that they are undesirable, so we will keep our Tesla coil at a lower voltage to avoid these losses, and to only generate the electromagnetic field. If we position a fluorescent lamp near the coil, it will turn on, because the electromagnetic field will give it enough energy so that the gas inside start emitting ultraviolet light, which is later transformed by a phosphor layer in visible light. The distance at which the lamp will light is quite short. The true way to use a Tesla coil to transmit power wirelessly is using another resonant circuit with the same frequency. In this way we can be much further and still generate an electric current as a result.
And finally, I thank my team for their collective efforts in producing this presentation. And thank you, ma'am, for providing us this opportunity.